Hello everyone, you're watching our project called the Autonomous Security Patrolling Sentinel. Before I proceed with the project details, I think it's best to introduce the team first. We have Alaya and Gabriel, who are both majoring in computer engineering, and we have me, Robert, who majors in computer and cybersecurity engineering. What our project is a security robot that can map an area using manual control, autonomously patrol this mapped area, detect active violence, weapons, and dangerous objects, recognize faces of registered criminals or security personnel, send incident reports to the headquarters, and respond to the incidents that were detected.
So in this slide, we have the mechanical summary of the robot, as we mentioned in the proposal. This is just summary. You can see all the mechanical parts labeled. We did install the safety bumpers and steel support beams so that the middle part of the robot is reinforced. Similar to the mechanic summary, we have the electronic summary. Now we do have all the motherboard complete with both the Jetsons Nano and Orin in place. We have the IMU module, the USB hub with 8 ports installed in the motherboard as well. We are utilizing the PCA 9685 with 16 PWM channels to control all the motors. We do have 4 DC motor drivers. For the robot API and firmware summary, we are using both Jetson Nano and Jetson Orange to control, sense, and respond. We utilize both Jetsons as a bridge between front and the robot hardware, such as the motors and the sensors, the camera, the LiDAR, the encoders.
The first demonstration we're going to be doing shows how the front end and the server works. So we start by logging in because we only want the right personnel to control our robot. And immediately, when you log in, the very first thing you see is our very simple home dashboard. So you have here basic statistics on the robot, and here you have a really cool pie chart showing all the incidents and the different kinds of incidents that have been recorded. Then here, let's go over to incident reports. This right here displays the table of all the incidents that have been collected and stored in the database. So this is all the incidents that our robot has recognized and sent to the server. Live feed and manual control. Live feed is not working yet right now, but later you will see it working in the later demo videos. For now, let's focus ourselves on the manual control. So if we toggle manual control on, we can use our keyboard or these buttons to manually control the robot while looking at the live stream. Let's revert back to automatic mode. And then we have register personnel, right? So you can register new security users here. And we can go ahead and add a new user. Let's name him Gabriel. And then we can also add an image for him so that facial detection would work on him, right? So let's go ahead and add him an image. This one looks nice, right? And then we submit that, and user is already created.
Here you can see me initializing the procedure of hybrid mapping locally, directly controlling the Jetson through TeamViewer. We start in the living room, and I can command it with the arrow keys in the keyboard or WASD. In this mapping procedure, we are utilizing the Hector-SLAM algorithm or simultaneous localization and mapping, where it can locate where the robot is and map at the same time, generate a map. We do have to go quite slowly for it not to create artifacts in the map. And here it finishes our map. Here in this demo, you can see me initializing the procedure of following the pathfinding route to reach a goal shown as the red arrow in the top right screen. And now that the robot starts moving to self-correct when detecting unknown local map issues, for example, person, people, or animal.
In this second demo, you can see again the autonomous driving / patrolling around the apartment. And then it goes on to start detecting all the people in the room. So the first person detected in this case is my colleague Robert. So the robot now proceeds to get a closer look at the individual, and as you can see, now robot is showing a knife or the weapon. In this moment, as you can see also in the right, through the logs, the robot was able to successfully detect the weapon and also classify it. So now we're gonna go ahead and look at the incident reports. Let's start by looking at the image. So as we can see, this is the image or the that is cut from that instance, which shows Robert holding the knife. We can also see that it successfully detected Robert in terms of face recognition. So Robert was recognized successfully.
And here is another demo, this time with 2 people involved. So right there you can see that the robot collides with the box because the box isn't the same height as the LiDAR and therefore it wasn't mapped properly, but the robot deals with it anyway. And right there at the right side you can see a huge chunk of text, which just means that the AI detected something. Now let's go back to our front end and check the incident reports if anything has changed. And sure enough, a knife and a handgun was detected. So we can check the images and you can see the handgun that got detected. You can also check the location of where it happened, which happens to be that part of the map. And it also says that a knife was detected. If you view the images, you will find the knife that got detected as well.
Here in this video, you can see me playing with the pose estimation algorithm, and you can see me doing some tricky movements and poses, including from the back and the front, and attack poses as well as sitting. The algorithm should be able to detect it as a violent act. And in the top right, you can see again that it was detected as a threat, and it has a very high confidence. It's important to remember that we did not integrate it directly in the robot because we do need to do a lot of fine-tuning in the future for it to work in a real case scenario with several people given the processing constraints. And thank you for watching the presentation. Questions?